Okay. Oh, just in time. There he is. Waiting for one more. Just in the nick of it. All right. Good morning, everybody. Hello. Welcome back. Today is going to be predominantly a work day. I'm going to give you time to work in your groups on the project that we began yesterday. But before I turn you over to that and send you into the Zoom breakout rooms, which means you guys make sure you're on the Zoom so you can connect. Are you both there? I'm missing an Eddie. Okay. Yeah, so you can connect with your group members there. I have, as promised, an example presentation for your viewing pleasure. Find the right button there. And we'll switch to this view here. Aha, there we go. Okay, so just to give you an idea of how quick and easy this project is intended to be, I put this thing together myself in less than an hour. Now, granted, I am the math teacher. I expect that I probably moved through this a little bit faster than you, and I didn't have to coordinate with group members. Maybe that makes it more efficient, maybe less. I don't know, but just to give you an idea, right? It's not supposed to be a long thing. A whole week is plenty of time, right? Relax, make the most of it. I like the way mine turned out. I think it's simple and clean and still looks nice. I've got some pictures there, and it coordinates, but it's still elegant. But you can go all out, all right? You can put lots of pictures in, right? Make it as fancy, dress it up as much as you like. There's points for creativity here. All right, so Archimedean solids. Oops, that button not? Come on, button. There we go. So formally, the proper definition is that they are a convex uniform polyhedron composed of regular polygons meeting at identical vertices, excluding the Platonic solids, prisms, and antiprisms. Okay? Those three groups also fit the same criteria, but we've decided that Archimedean solids are everything else that's outside of that. Okay? So those are, if it wasn't specifically excluded, you could almost say those were subcategories of this convex uniform polyhedron. Okay? In layman's terms, that means we're dealing with 3D shapes here that don't have any of those funky crisscrosses or dents, and they're all made of 2 or more matching polygons, okay, where no point looks any different from the other points. Okay. And minus the prisms and antiprisms. Prisms and antiprisms still get included with that verbiage, so we have to exclude those. Okay. So there's my formal and informal definitions. Here's the easy way to spot them, okay? They are mostly ball-shaped as opposed to some kind of can or a tube, like prisms can be elongated tubes, okay? These are not, you can't just stretch them out. They look ball-shaped. And they're very symmetrical compared to a lot of possible polyhedrons, right? That's being made of only 2 or 3 regular polygons really narrows it down. And in fact, they're so easy to spot because there's exactly 13 of them. If they are not on that list of 13, they're not an Archimedean solid. Sorry, guys. Right? So that's really the big kicker, right? Okay, and then here I have my examples versus non-examples. So we have the truncated icosahedron, there's one. The rhombicosadodecahedron. Notice we still got, now we have pentagons, squares, and triangles. But like we were talking about how you can't identify any special vertex, okay? This point right here with my mouse on it has the pentagon, 2 squares, and a triangle meeting together. And every other point you look at has a pentagon, 2 squares, and a triangle coming together, okay? No matter where I look. This one, pentagon, 2 squares, yep, they're all the same vertices. Even for the truncated icosadodecahedron. That's a fun one. Now, again, a couple non-examples. As we said, we are excluding all the prisms. So this pentagonal prism right here, made up of 2 or more regular polygons. Each vertex has the pentagon and 2 squares. So it would fit all criteria, but we specifically excluded the prisms from the Archimedean solids. They got kicked out of the club. Square pyramid. Also, two different regular polygons, triangles and squares here, but one vertex, on the pyramid we call it the apex, right, is distinguishable. We can tell that this corner looks different. It's all triangles meeting up. Whereas down here I have two triangles and a square that meet up together. So it's different. The fact that you could orient it means it's not an Archimedean solid. Okay. How about Eulers Formula? Does that still hold true for, say, the truncated icosahedron? Just to pick an example one. Let's count it up. This guy has 32 faces, 90 edges, and 60 vertices. So I think this is actually a different format of Eulers Formula than we've seen. They had the 2 on one side and I think put like the F, right? V minus E equals F plus 2, or however you want to manipulate it, all right? Still the same equation. So let's check. 60 minus 90 plus 32 should equal 2. 60 minus 90 is negative 30. Add 32 more, you get back to positive 2 equals negative 2. Check. Yes, they worked. Excellent. And finally, some cool historical facts about Archimedean solids, named, of course, after the Greek mathematician Archimedes. Okay, he was the first one to list these guys together and say, hey, these 13s, there's something special about them. Okay? You might know him from many other great works, such as, he's the guy with the lever. Give me a lever long enough place to stand, I can move the earth, right? Or the Archimedes death ray, right? Archimedes principle, buoyancy, okay? Fluid volume displacement, no, volume as fluid displacement, excuse me, right? All that. Brilliant guy. And also the truncated icosahedron, remember the example I used for Eulers Formula there? That's the classic black and white soccer ball shape, okay? As well as this relatively recent discovery, the carbon-60 molecule, the Buckminster fullerene, which has become the basic component for carbon nanotubes. Maybe you've heard about that up-and-coming technology, these super strong, super thin strands that we can make new super tough materials out of, okay? That's based on this shape. So it's pretty cool. All right? There we have it. That is my presentation on Archimedean solids. How did I do on time? I think I did pretty good. Between 5 and 10 minutes. Perfect. Okay, so there's an example of what something could look like, how you should present it, all that. I should have given you guys the rubrics. You could give me a score and grade me, see how well I did. Okay. All right, any questions there? Anyone confused? Anything I missed? You should always end your presentation with opening up for questions. Find my mouse there. No? All right, then that's all I've got for you for today. Let's put you into your breakout rooms. And you can get started. We need 1, 2, 3, 4 rooms today. So we've got group 1, Eddie G. There we go, Alani and Axel for group 1. Eddie, Alani, and Axel, I still need to know which topic you have chosen for your project. I never did get an email or confirmation on that. So please send me a message there in Zoom or an email with your chosen topic, okay? Jasmine and Noe there, and for and Fatima. All right, there you are. Go ahead and get started. You have the rest of the period to work.